Hey, boys and girls, we're back. This is lesson 6. You are interpreting fraction multiplication as scaling. Okay, so the objective for this lesson is you can explain how the size of a product, okay, the answer to a multiplication problem, compares to the size of one of your factors, okay, by one of the things you're multiplying with. So we're going to go ahead and we're going to start on page 206. We're not going to do the Spark Your Learning. We're going to go straight to the Build Understanding. I'm going to go to the interactive lesson just so it's easier for me to write for you guys. So it says a roller hockey puck typically weighs 1/4 of a pound. An ice hockey puck typically weighs 3/2 times as much as a roller hockey puck. Okay, so some important things that I'm going to go ahead and highlight is the roller hockey puck that weighs 1/4 of a pound. The ice hockey puck that weighs 3/2 times as much as. This times as much as tells me that I need to multiply the roller hockey puck, the 1/4, by 3/2, because what it's telling me is that this roller hockey puck is 1/4 of a pound, but the ice hockey puck doesn't equal 3/2. It's 3/2 times as the roller hockey puck. Okay, so there's some of these that go on ice, and there's some of these that go on regular hardwood floors that you play at a roller rink. Okay, so part A wants to know, it wants us to complete a multiplication expression to model the problem. So they already have my 1/4, and they have the times as much as there, so we just have to figure out, sorry, the next part. Am I multiplying by 1/4, by 2/3, by 3/2? Well, our fraction is 3/2, so we're going to multiply by 3/2. And notice that our numerator is greater than our denominator. Okay, so this isn't 2/3. We're multiplying by a number that is an improper fraction. Okay, so let's check our work, and that's correct. We're using multiplication to find 3/2 times as much as 1/4, just like our problem said. So the expression for that is 3/2 times 1/4. Part B says, how do factors from part A compare to 1? So let's look at our two factors, 3/2 and 1/4. Is 3/2 greater than 1, less than 1, or the same as 1? Well, our numerator is greater than our denominator. That tells me that it's greater than 1. If this numerator was a 1 over 2, then it would be less than 1. If my numerator was 2 and it was over 2, then it would be the same as. But my numerator is 3, and that is greater than 2, so it is greater than 1. Let's try 1/4. This numerator is less than 4, so it must be less than. If it was to be greater than, this numerator should have been greater than 4. And if it would be the same as, this numerator should be the same as 4. So this one is less than. Let's check our work. That's true. Make sure you have this in your workbooks, okay? Part C. What is the product of a number multiplied by 1? So it's asking us, what is the answer to a multiplication problem if the number is multiplied by 1? Is the product greater than the original number? Is the product the same as the number? Or is the product less than the number? Well, we know that the answers to all multiplication problems depends on what you're multiplying it with. If I'm multiplying by 1, I know my answer must be the same as what I started with. So if I do 5 times 1, it's going to be 5. So it's going to be the same as the number. That's correct. The product of 1 and any number is that number. Part D says, will the product of a number multiplied by a factor greater than 1 be less than or greater than the number? Let's think about our problem here. When I'm multiplying 1/4 times 3/2, is my answer going to get greater or smaller? I know if I multiply by 1, it would stay the same. So if I'm multiplying by something that's greater than 1, is it going to get bigger or smaller? Right, it's going to get greater than. Think about that 5 times 1 that I just gave. 5 times 1 stays as 5. When I start multiplying 5 times 2, that's 10. 5 times 10, that's 50. The greater my multiplier gets, the greater my answer gets. And there we go, that's true. And now it wants me to make a prediction for part E. Predict whether the typical weight of an ice hockey puck is greater than, less than, or equal to the typical weight of a roller hockey puck. Explain your reasoning. Remember, the whole point of doing all this is because we want to know if the weight of the ice hockey puck is greater than or less than this 1/4. Okay? Think about our expression. We're doing 3/2 times 1/4. This is how much the roller hockey puck weighs. The ice hockey puck is the answer to this problem. What it wants us to do is making a prediction. It doesn't want us to solve, it just wants us to make a prediction based on what we just learned. If I multiply a number by something greater than 1, we said it's going to get a bigger answer. So when I multiply that 1/4 by that 3/2, which is greater than 1, is my answer going to be greater than, less than, or equal to the 1/4? If you said greater than, you're correct. The ice hockey puck typically weighs more than a roller hockey puck. Since the 3/2 is greater than 1, an ice hockey puck typically weighs more than 1/4 pound. They're not looking for an exact answer, but if they were, all you would have to do is do 3/2 times the 1/4. 3 times 1 is 3, 2 times 4 is 8. Okay? So the 3/8 is greater than 1/4. And how would we know that? Now I have to make my 1/4 equal to a denominator of 8, so that would be 2/8. Now we have 2/8 is the roller hockey puck, and this is my ice hockey. Okay? And you can see it did end up being greater than the 2/8 or the 1/4. These are equal. Okay, let's go ahead and move on to the next question. Okay, so a new skateboard ramp is designed that has a width that is 2/3 of the width of the ramp shown. So there's another skateboard ramp that they're making, and it has a width that is 2/3 of the width of this ramp here, which is 5/6 of a yard. Okay. So it wants to know, is the width of the new ramp longer or shorter than the width of the ramp shown here? So remember, think about what we just learned. If I'm multiplying by 1, it stays the same. If I'm multiplying by a fraction greater than 1, it's going to be a greater. If I'm multiplying by a fraction that's less than 1, it's going to get smaller. So you have to ask yourself, this is 5/6. Obviously, it's less than a full yard. Okay, it's not 1. And now I'm multiplying by 2/3. Is this greater than 1, less than 1, or is it the same as 1? If I'm multiplying by something greater than 1, it's going to be longer. If I'm multiplying by something less than 1, it's going to be shorter. Okay? But part B says, how do you know? Support your answer. So if you said longer, explain how you know it's longer. So basically what I just said. The only way it could be longer is if you multiply by something greater than 1. Okay? Did we multiply by something greater than 1? If you said shorter, the only way that could happen is if we multiply by a fraction that's shorter or less than 1. Did we multiply by a fraction that's less than 1? If so, then that's what you would explain here. Okay? Part B says, what factor... So actually, let me just show you the sample answer here, which is basically what I just said. But you are finding 2/3 of 5/6 yards. When you multiply by a number less than 1, you are finding part of the number, so the product is less than that number, right? Basically what I said. If you're multiplying by less than 1, your answer is less than 1. If you're multiplying by greater than 1, your answer is going to be greater than 1. Okay? Part B says, by what factor could the ramp be resized so that it is wider than the original ramp? So if you wanted to multiply this ramp, the 5/6, by a number to be greater than this one, or to be greater than 1, what would we need to multiply by? 3/2 or 3/3? 3/3, remember, my numerator is the same as my denominator, which means that's 1, so it's going to be the same. We want it to be wider, okay? We want it bigger. 3/2 my numerator is greater than my denominator. So that means my answer is going to be greater, okay? And then explain your thinking again. How did you get that answer for B, okay? Make sure you have this. For A, you're not just telling me longer or shorter, you're also explaining. For B, you're not just telling me 3/2 or 3/3, you're explaining, okay? And that's basically it. The next part that you need to complete is the check understanding on page 207. Let's zoom in and look over that really quick. It says a vehicle traveling 70 miles each hour needs 1/10 mile to come to a complete stop. Engineers are designing a new vehicle that can come to a complete stop in half of that distance. How does the stopping distance of the new vehicle compare to the stopping distance of the original vehicle? So, did the stopping distance become less than? Did it stay the same? Or did it get greater? It wants you to compare. It's not really looking for the exact answer. It wants you to compare the two stopping distances of from the original vehicle. This one takes 1/10 of a mile to come to a stop. They say that that the engineers are designing a new vehicle that can come to a complete stop in half of that distance. So is the distance going to be shorter, greater than, or the same? Write that down over here and give a small explanation. For the next part, from numbers 2, 3, and 4, watch the directions right here. Okay? It says a 3/8 yard long toy bus is rescaled as modeled by the following expressions shown in numbers 2 to 4. Use shorter, longer, or same to describe how the length of the rescaled bus compares to the original length. These are all very important. Okay? It wants you to use shorter, longer, or same to describe how the length of the rescaled bus compares to the original length. And remember, the original length is right here, 3/8 yards long. And you can see that in each of these, they each have 3/8, 3/8, 3/8. Here they multiplied by 8/1, okay, 8 ones, 8/8, and half. So what I multiply here, is it going to be shorter, longer, or the same? And I multiply here, is it going to be shorter, longer, or the same? Shorter, longer, or the same? Okay. If you have any questions, boys and girls, as always, comment below, and I'll see you today at 1 p.m.